Frequency coordination form 15 minutes, then displaying the database in detail 15 to 20 minutes is 30 minutes. Okay. जूम मीटिंग चालू बंद करना बंद कर दिया सब तो बंद है उधर से बंद कर दिया हम लोगों ने मतलब टैब क्लोज कर दिया था दस सेटिंग चालू यार पांचवा देखो आंखों में पहना ओपन use the mouse mouse आना शादी समझी नहीं Stop. Battery. Start. So, please may I have your attention, everyone. We will now begin with the frequency modulation form filing, which is basically the requirement for understanding how to fill the ID, and all the definitions mentioned in the prior presentation would be very helpful in filing out this form. So, firstly, the name of the satellite would be NewSat. The short duration mission or a long duration mission, it depends on the months or the years the satellite is going to be active. So, we are just going to keep it N for right now. N and Y are the two letters which are basically signifying yes and no. So, in this software, we presumably use Y for yes and N for no. So, in most places where there is a single digit letter, so please understand that it's just a yes and no question. While moving on to the orbital details, firstly, the number of orbits would be one. Then inclination angle, as I suggested, it is taken in reference to the equatorial plane. And for the satellite, we are just going to keep it at 9.6. Then number of satellites in the plane we will assume is just a satellite, it's just our satellite. Then period, for a period is basically a revolution orbit which completes one cycle which is completed basically, and it takes 96 minutes. The average is 350 kilometers, the perigee is taken as 350 kilometers. So this is an equidistant orbit. We are not at an angle where we can take the difference. It is not a complete ellipse, it's mostly circular. So that's why we are kept at same. The major reason for keeping it same is because we are getting a geosynchronous orbit, and which is easier to communicate with. Then moving on uplink, as I had previously mentioned, the uplink is taken in respect to the satellite. So basically, uplink is the receiving part. So here the satellite is receiving data from the ground station which is present. Ground station is basically handled by any personnel, or it can be handled by auto-coded repeater. So in place of a personnel which is sitting down there, it's going to be for 5 to 6 hours on which the satellite will be scheduled. And when the satellite is scheduled via taking the orbital details, that's the time when the person will activate the ground station which will send commands. So in this satellite, which we are taking as an example, the commands which can be sent is basically voice repeating, telecommands, and DGPT. Voice repeating here is basically communication of transmission of messages over the cable. So it can be taken as something like we are sending certain messages through our voice notes, and the packets is being received, decoded. So the packet gets decoded is basically where the carrier wave. So a single wave doesn't carry. We need a carrier wave which is more powerful. More powerful carrier wave will transmit our original packet, which is basically hello. I'm sending a hello to somebody, to another person. It is getting stored. It is getting repeated over there, and then it will go to another person. So basically, a hello will be repeated and going to another person. It's just like a call. So while you're calling somebody, you'll call and say hello, and they will receive the calling exactly. That's the basic gist of how it works in voice repeating. In telecommands, basically we are telling the satellite to either switch off its stable mode, power saving mode, or data communicating. So these three modes are present in the satellite over which we are continuously toggling. So it and digibeating finally is sending messages. We send a text message. It's mostly in Morse code. So Morse code, as some of you might have seen through popular media, is basically dot and dashes, and it's used in submarines, radar applications. It's quite common, and it's taken as a key language in radio communications. So digibeating is basically sending the Morse code message to the satellite, which is a repeater, which acts as a repeater, which will send back the message to the ground station. So here again the carrier will carry the signal, and it will again send the signal to a carrier wave. So the free path loss will be low. Then satellite receive antenna gain. So the receiver antenna which is present at the satellite for PLESat 0 was Nago S770S. So this was a standard antenna which was used. And here we got the gain as 3 dBi and 2 dBi. So dBi is taken as an index of gain, and it is a reference unit. So it doesn't have a direct value proportional. dB has a direct value proportional and conversion to hertz, but not dBi. Then the antenna radiation pattern. Basically, the antenna, whenever it's receiving, as you might know, antennas have a circular pattern while receiving any objects. So antenna surrounds itself with the electromagnetic circular wave. And in our case, it was only directional. Rather than being singularly directional or being in any other kind, it was only. So wherever it was in this range, it could receive the signal, a range of around 20 meters. So in 20 meters, it could receive the signal above 180 degrees. That's only directional pattern. Then the satellites receiving noise temperature. Noise temperature is basically how much distortion takes place, and the distortion taking place at which temperature is taken into consideration, because that's how much distorted the signal would be, and that's how much free path loss we would have to calculate. So it was 200 Kelvin. Then uplink frequency range was for voice repeating was 437 kilohertz, which lies in the UHF range, ultra high frequency band. So as sir have suggested starting PPDs, there are two bands which are utilized. One is VHF and another is UHF. The first voice repeating was done under UHF, and telecommands and DGPing was done under VHF. So these two separate bands were allocated to us free of cost by IT for being a part of the Ham Reading Club crowd. Then the bandwidth. Basically, how much area can the band suggest? So basically, the most prime example would be if you're traveling on the road and there is a lot of traffic. So if there is a lot of traffic and the lane is not wide enough, so the traffic will be congested for more time. And if the lane is wide, if the lane is wider, if it's a four-lane road, the band traffic is easier to flow. So that is the same mechanism which is working here. Instead of cars, there are electronic signals. The wider the band, the more the signals can pass easily and quickly. So here it was 12.5 kilohertz. The designation emission, as earlier I had explained. So for voice repeating, again in the starting it's the bandwidth. 12K5 is 12.5 kilohertz. Then F is taking for the modding. So what modulation takes place? Frequency modulation is taking place. Basically the frequency is heightened so that the message can be carried forward. And finally, 3 is for voice repeating. 3 is basically stands for voice repeating or uh, voicing vocabulary words. And finally, E represents the type of emission which is carrying. And in telecommands and repeating, it's same as EDRS. So it's a digital subcarrier. That's why at the end it's D for a digital subcarrier. And in voice repeating, it wasn't E because it was an image. It wasn't exactly a carrier which was carrying it. It wasn't an exact packet. So that's why we had E and T. That's the difference basically. Then again, we mentioned the carrier frequencies over which the signal is being carried. For further above was the uplink frequency range, so the range which it can receive, and carrier frequency is basically the carrier signal which will travel or which will carry the packet. So it is 437 megahertz and 145.9. Polarization is linear. Polarization is a concept which we can ponder for a long time, so we will just drop it. But we can keep a singular point in mind for satellites, mostly amateur satellites, it's linear polarization. Max value is calculated through the formula which is given in the PPT. For this, we have taken 16.99 dB and 16.9 dB. Max power density was also minus 23.97. The minimum value of power input to the Earth station. So yeah, now ES stands for the Earth station. So here we shift, not talking in respect to the satellite again and again. Here we are talking in respect to the Earth station. So the Earth station's minimum value power input is 0 dB. It was operating basically, if it's even not receiving anything, it will still catch. Basically, it's wide enough to catch even low power signals. That's the concept for keeping it at 0 dB. Minimum power density is minus because the signal sometimes becomes so small or they are so minute that they can even traverse in minus 40. You may think of it as a very small signal. Like if it's in minus 40 and it's a power formula. And even though we are taking it in consideration, so you can understand how much for the range frequency is present while operating on full frequencies and how much distortion can take place depends. Then the required CN is carried is 9. 9 again, it's calculated the formula of the power is minus the power of the noise. Uplink of the Earth station is basically the Earth station is receiving something now, so it can reach up to 3 dB maximum for both voice repeating and digipeating. And then there is gain again. We are talking about the Earth station antenna, which was a standard antenna developed by our team. Then the pattern is again taken as omnidirectional. The antenna beamwidth is taking 70 degrees elevation plane because of Mumbai's lat long. So Mumbai is present at 72 lat and 19 long. And in accordance to that, the elevation plane was taken into consideration. As you can see, lat I missed it. So lat is 19 and long is 70. I'm sorry. Then downlink is basically the satellite transmitting data now. Basically, the satellite has received some message from the Earth station and now it's transmitting down its own uh, version of the reception. So the satellite antenna is gaining at 2.15 dB and 2.15 dB. This is taken into consideration through the satellite's antenna which was present. It has a generic gain of 2 to 3 dBi, the Nagoya 770S. The antenna radiation pattern is omnidirectional. Frequency range was 145 and 145. Yeah. So you can see a change basically. We were up, the satellite was receiving UHF but not transmitting at UHF because the power depletion was present. We didn't have so much power to transmit it again at 437. We were transmitting it at 145 from the satellite. Then again, the beam width and the designation emission is taken. So yeah, almost all the details are similar instead of the power. Basically, the minimum value of peak power and minimum power density changes because of the satellite's limitations. It cannot receive or it goes even lower than 0 dB, which was present in the Earth station. So that's the difference when receiving and transmitting. So now we will move to the software where we have imported the values and filing. So now this is the SpaceCap interface, the opening interface. SpaceCap is basically a part of the SAM software suite. So SpaceCap is mostly utilized for Lotus findings. And the other softwares are utilized for three things. Most of the things are data management. Second is environment testing factors management. And third is finally giving the GRMS, which is the frequency management. But here we'll be focusing on the API, which is the most essential part of filing a ITBU notice. So here we will open a database which is reminiscent of the frequency coordination form which we had just filed or we just went through. So the SAM software just got an update finally after a few years of being shut down. So we have finally received version 10, which will probably have less bugs. So I'll explain the bugs from the way while explaining the entire OS. So we are now just going through this. Begin with yeah. So hopefully it's visible better than the procedures we had taken for screenshots. So yeah, firstly the date and the date. Then coming to notifying administration, as we are in India, we say India. Then identifying the network here for some reason it's coming beliefs that's here. That's fine. We had modeled the entire notice on the basis of our previous interpretation. Number of orbital planes, as you can see, we have selected one. The reference body is taken as a constellation none. So you may have heard of constellations. Many are present, but we are any relation to stargazing or understanding the astronomical figures. So therefore, we are not taking any constellation to be considered. And short duration mission, yes, we are selecting A1 GSS. The, these are the indexing values A1D, A1A. They were in tandem to the frequency coordination form. Then there is orbital information. So the orbital plane ID will be taken as 1, inclination angle as 9.6, satellites in plane will be 1, period and mm is taken as period and mm is taken as 96. Okay. Then for some reason it's 30. Okay, fine. It's not going anywhere. So apogee and perigee are mentioned as 350, 350. Minimum altitude is also taken as 350 because we are considering the entire plane as circular. Then we will fill out two indices, one for the global beam being dx and another for being rx for uplink and downlink purposes. Then we will move to beam. Beam is basically the channel which is coordinating information. In beam, we will be filling with the designation. So this is the RX beam, GBL RX. GBL is the abbreviation for global and RX is the abbreviation for distributed. The isotopic gain is taken as 3 dBi. Then the coplanar radiation is taken as 610 for being ND space. So 610 is basically taken for low power satellites, and we are a low power satellite, so we will be selecting that. The orbital link E4A, yeah. Orbit ID and sat ID would be 1 because we are the only one present in that orbit and the only satellite present in that plane. Moving forward to group. So in group we will be selecting the station. So the space station is in amateur radio satellite service, so therefore we will be selecting EA. And for class of station nature of service would be public correspondence. So the satellite will be open to all. If there are other functions, we can select for correspondence, limited public correspondence, correspondence from private agency. So yeah, there are available for making multiple usages out of the satellite. Finally, the area of service to the distant geographical destination will change as the satellite. Here the IT important part comes into play in limiting the boundaries of verification and application of satellites. So here we have selected it for because it's an amateur radio service satellite, so it will be available to all TV. But there are also specific regions, specific countries, and gaining specific access. Given the specific software or the specific frequency coordinate can be utilized. IoT gives you the option for being specific, and it also helps you in understanding the coordination between countries. So this being an international body, we don't require to find different files in each country where we can be accessed. That's the reason why it's so useful. That's the reason in 2000 it was finally centralized digital medium, it was the most efficient way of filing satellites API. The characteristics to the operating agency would be Government of India, responsible admin, government admin, Government of India. Period of validity can be, it's a short duration mission, so we can say we have kept it 3 because of being noted. Sometimes they give out the error from saving each and every detail. That was 9.1. They hadn't saved most of the frequency characteristics that are present. Neither they were able to save the IDs properly when shifting in domain. So group is a specific domain present other than nodes. So in group there are two more sections. One is characteristic, one group of frequency and general characteristics. So then you should know the general characteristics properly, and hopefully they will work on it in version. So emissions as it's in regards to the general emission type, and then there are the carrier frequencies. Okay, so yeah, this was the exact problem I was talking about. It doesn't say within the as you can see, there is a emission. So now you'll have to fill it out again completely. Just give me
Right format. This will be uploaded on a spot, right?
but no, give them the database, and then through the database we check it for. Yeah, we have to figure this out. I don't know how it's lost. It's lost. So, like, Okay. After filling out this table, we can check out the carrier frequencies through this box. For each designated division, we'll get the carrier frequency corresponding to it. For well, K5F3E, which is a voice repeating designated division, we get the carrier frequency in 437 gigahertz. And while it detects well, K5F3 as the distributing or APRS, and it automatically detects it in 145.980. So that's how it works and understands how to do it. Hopefully, it will save it again. This is the most common issue with this software. It kind of forgets if you have input something and then it leaves it. Hopefully, it doesn't do it again.
Type करे तारीख है ना रे. It's specific. Restart the software. Anyway, this thinking connecting to a database that's not working. So you have opened twice. Open data. Close this. This one. This one. We are select no side persons. Then we go to API. This one. Then we have to go and select this. Then we go to API. This. I want to see. This.
So, yeah, it's again a little bit group emissions. Yeah, it's hopefully saved right now. We don't have to again enter everything. The frequencies have been added and the entire band is taken into consideration. That's fine. So this is the frequency section where each and every frequency with the frequency range which we have already. Here we have most likely from 145 to 238. Then in the associated Earth station, as the ground waves related to our satellites system. Here we have to enter the associated Earth station name, which is the ground station. Then the classical station will be TA again for being a generated satellite. And then the class and nature of the service investigation will be open to all public correspondence. That law would be that law. And finally, the maximum maximum we gain will be 3. Similar to the antennas gain, officially gained through its data feed. And then the beamwidth will be 78 degrees, 78 degrees. Inclination beam area 78 degrees. According to the form we have filled. Then the pattern ID will be taken as 608 for ND2 near to north, basically, appended. So this are all the consideration factors which have been taken into place. And we have completed the RX part, global RX part for the visibility. Now we will the DX part, which is the second interest which will be buying. So the major change would be DX and the port data radiation will be 60609 as is the relative pattern. This pattern ID can be verified through the ID. The ID is index which is available at their website in the official degree, which is given to all the participants, and you can download it from that website as well. So you can find out the work evaluation ID from there. Then the orbital link will be again first work ID one and sat ID. Here also there will be significant changes other than EIRP being zero. So we are taking the EIRP as zero here because as I suggested earlier that this is in regards to the Earth station and there is a separate visibility. So here it has saved the frequencies for some reason and it wasn't present in the RS, but it's good for us. As you can see, the designated initial frequencies for the mixing reading would be maximum power density is minus 41, maximum peak power is 0, minimum peak power is minus 3, minimum power density is CNN is 86.2 in total kilos. So the CNN is calculated according to the detailed formula which was given in the PPT earlier. And the same is done for the digitally as well. 12K 5F2. Now moving on to frequencies, the range is taken from 145 to 146. In VHF, then the associated earth feature values would remain the same. Being CWL, here we have the ample other than the name itself. Again, the coplanar radiation ID pattern will be changed. You can go to the entire list which is available in the detailed document present at IDU. So yeah, after completion, we can use the notice and then we can just validate it from this particular view. The validation is necessary as it enables an in-ground check rather than wait to the agency, but we generate through here and we don't get in error. Once the validation is complete, and as you can see, W is written everywhere. W is basically suggesting that we have done everything, and we have 8 warnings: warning the fine, fatal errors aren't, fatal F, which is given through a red notification. This will have completed our process of filing an API interest without any errors. So now we can just transmit in email this MDB file, which is the entire database which we just filled out to the agencies. And then they will carry our request to the IDU. And finally, the IDU take into registration the entire details. And then we will allocate it to certain frequencies that we have entered. The entered frequency will be taken into consideration while other frequencies are being allocated. Details are allocated. The funding has completed the process of identifying the study requirements for satellites and the immediate release will be taken into account. It will be used. So that will be the completion of detailed API filing. Thank you for all being part of the audience. This is hopefully you have skills. You might have understood the detail that required filling out the API. Thank you.
Thank you. Thank you, Ryan. So, uh, there are few questions from the audience. Please, question that why you were filling the IT believes that good discussion with the Yusuf team. Could you tell me about the points you want to implement here where you got some benefits?
When all the first time we have the taking assistance from the ISRO personnel and the team. So they gave us some pointers which were quite beneficial. The first pointer was that the formula that we just mentioned was completely. We have a mix formula for we were taking less the commercial formula. We used the detailed formula and they also pointed out that in the container gauge pattern. So the 607 and the 610 one year they used the index one, which was clear. They get consideration, read through it, and then they got the details. And the time you get to figure them the software mistake that like it will not carry frequency for the rate, but it will be for the TV. So that had taken place multiple times in the whole course, which has been rectified in the so yeah, the value was creating the same values in frequency will be overcome by again going to the entire code. Most I would say the lethargic process would be again again to the code, even slide error. Even slide errors can't be given consideration because the fatal error pops up even when the value you have figured is at a limited. So you have to turn the off again, open just and try to correct it. So it's a repetitive process. It takes some time to get completely. Who will the number? Would you like to tell me the most problematic error the making is using? Second would be the value using, not saving the value. So yeah, it's a you have to keep on going really research and then go to validation. So each and every time, each and every section before going to validation, we will be able to in overcoming some saving it take place in this database. But the software relies on Microsoft package, which law or Microsoft stop giving updates or stop focusing executing on the database. So the database is still based on that, but it's a very complicated database. It doesn't have any security aspects or whatever. But yeah, it's a database. And it will have to be